Do you know there is a law of thermodynamics called the Zeroth Law? The Zeroth Law serves as the fundamental for the first, second, and third laws. But for you to understand the Zeroth Law of thermodynamics, you need to understand the concept of temperature and thermal equilibrium. You know that temperature of a system is the degree of hotness or coldness of that system, or technically, the average kinetic energy of the particles of that system. Thermal equilibrium is a situation whereby two or more systems are in contact and there is no net heat flow between the systems, or the amount of heat in one system is the same as the amount of heat in the other system. Take for instance, we have two systems, system A and system B, which are in contact. Let us assume that the temperature of system A is higher while the temperature of system B is lower. This means that A is hotter than B. Now, when A is hotter than B and they are in contact, it is expected that heat must flow from A to B, right? Let us take another scenario of the two systems A and B, where the heat flow continued until the temperature of A dropped and that of B increased. Now, what is expected is that there is a heat flow from B back to A. Take another scenario where the temperature in system A and the temperature in system B are now equal. What do you expect? Of course, there is no net heat flow between A and B. This situation where the heat contents of two systems are equal, but there is no net heat flow between the two systems, is called thermal equilibrium. Now, having understood the meanings of temperature and thermal equilibrium, let us now look at Zeroth Law of Thermodynamics, because the law centers on temperature and thermal equilibrium. But instead of two systems, the Zeroth Law talks about three systems in contact. So let us use three systems, A, B, and the third one, C. Now, this is temperature of A, temperature of B, and temperature of C. Now, if the temperature in system A is equal to temperature in system C, and the temperature in system B is also equal to the temperature in system C, this now implies that the temperature in system A is also equal to the temperature in system B, even when A is not directly in contact with C. And this is exactly what the Zeroth Law is talking about. And it will now lead us to the Zeroth Law statement, which states that if a system, say A, is in thermal equilibrium with a system C, and B is in thermal equilibrium with system C, then A is in thermal equilibrium with system B.